This is the Module 9 SAS video. So the first thing that you're going to want to do, as usual, is make sure all the files that you need are in one convenient location. So here's the folder that I've been working out of. Notice we've got the Module 6 through Module 9 SAS code. We also have the code book and our data set. So I'm going to click on the Module 9 SAS. All right, now that we've got our code open, let's take a look at it. So the first thing we're going to need to do is import that data set. We've done this at the beginning of the last several videos, so I'm just going to go ahead and run this code. Notice, checking my log, I do have those 6,604 observations with 275 variables that I expect to see. The next thing I'm going to do is build a contingency table. Now we're going to create a contingency table of the variables education level and race. We've seen education level before in a previous video, so let's look at the variable for race. So I'm just going to copy the name of this variable, and I'm going to go over to my code book and search for that name. All right, so here is the information on that variable. Notice this variable takes 6 different values, and these are the different value labels. All right, so let's run this. All right, here is the contingency table. Now when SAS creates contingency table, there's a lot of information here. Notice along the left-hand side we have education, and along the top we have that race variable with their different values. Now one thing to notice here is that these values do just have the numeric values. We could switch that over and relabel these like we did in the previous video, so this would be more informative. Now looking inside each of the cells, SAS gives us 4 pieces of information. It gives us the frequency, the percent, row percent, and column percent. Now the row and column percent, those are going to relate back to those conditional proportions that we looked at in the Module 9.1 notes. The frequency here, that is the count, and then the percentage, that's going to be the marginal proportions that we looked at. Probably not the marginal proportions. These are going to be the proportions for a person that has education level 1 and race 1 out of the overall total. The marginal proportions are going to be given over here either in the last column or down here in the very last row. All right. Next, we're going to look at how to create side-by-side bar plots. And again, we're going to look at race and education level. So the first one we're going to make is the side-by-side bar plot. We're going to use the proc sgplot procedure that we've seen before, and we're actually going to use the vbar statement just like we did before. The only thing we're going to add in here are these 2 statements, are the only thing that differ from what we've seen before. The group, what the group is going to do is that's going to add in that second variable that is going to group the other variable within 1. And then the cluster, the group display equals cluster, that's what tells SAS you want the bars to be side by side. So let's run this. There's our side by side bar plots or bar charts. And to get the stacked bar plot, the only thing we have to redo is remove that group display equals cluster. And so there is our stacked. Next, we can look at scatter plots. So for scatter plots, we're going to look at 2 different quantitative variables. They are height in inches and weight in kilograms. So again, we could look at each of these variables in our code book. In particular, let's look at the height in inches. So I'm going to go back to my code book and search for this variable name. All right. Here we go. It took me a minute to find it. We are our reported height in, there it is, reported height in inches. All right, so notice that this variable is actually a calculated variable. So on the actual survey, people reported their height in feet and in inches. And what they've done here is they have converted that just to inches. And so you've got some information about that here in the value label. So going back to SAS, what we're going to do is we're going to create a scatter plot of height and weight, and we're going to see if a person's height can predict their weight. So I'm going to have height along the x-axis and weight against the y. So running this, we've got a nice scatter plot here. Notice that we have a positive weak linear association. So next we could actually look at some regression. So the first thing I'm going to do is calculate the correlation between those two variables using the proc cor. So running this. This is going to give me the correlation procedure between the two variables, height and weight. Each of those variables are summarized. And then the other nice thing to notice here is we've got the Pearson correlation coefficients, and it gives us a correlation matrix here. So what we're looking at here along the diagonal here, this is going to be the correlation of height with height. Well, any variable, the correlation with itself has to be 1, so that's why you have the 1 here. And then weight with weight, we also have a 1 here. So let's talk about these numbers right here and here. Notice that the variable height had a sample of 6,460. The reason for this is, remember, we've got some missing values. So that's why for height against height, it used 6,460. For weight, you have 6,245, so that's why that count is here. Now, in order to calculate the correlation between height and weight together, we can only do that for observations that have both height and weight. So that's why this value is smaller than the other two. There were 6,215 observations in the data set that have both values of height and weight. So this is the correlation between height and weight. We see that it's equal to 0.467, which suggests a positive weak association. Now notice if we looked at the correlation between weight and height, it is the same. And that's because of that fact for correlation, it doesn't matter if we switch the order of the variables. Now do keep in mind for the regression line, that does matter. All right, so next, the other thing that we had in the notes was that proc correlate core by default calculates the Pearson correlation coefficient. Remember that you might want to do the Spearman rank correlation. If that's what you need, the only thing you have to add is the word Spearman after the name of your data set. So I've done that here for illustration. Now the last thing we need to do is we need to find our regression line. And we're going to do that using the proc reg statement. Now one thing to notice here is after I've named the data set, I've added in this extra thing right here. It says plots max points equal none. When you have large data sets, you want to add this in, otherwise SAS isn't going to give you all the plots that you need to look at the residuals. Here I've got my model, and you're always going to list the y or the response variable first. So I'm trying to predict a person's weight based on their height, so I have weight is equal to height. Running this. All right, SAS gives us a bunch of output, so let's look at what we have here. Under the reg procedure, notice it tells me the number of observations read and the number of observations used. Remember, the reason it's not using all of them is we can only use observations that have both observations for height and for weight. The analysis of variance table, we'll come back to that later on in the course. But what we want for right now are the parameter estimates. So notice SAS is going to give us an estimate of the intercept. This is the intercept for the regression line. And then next to the name of the explanatory variable, in this case height, we have the estimate for the slope. So this is the estimated slope for the regression line. Now recall that in order to use simple linear regression, there are two assumptions we need to make sure are satisfied. They are that the subjects and the sample are independent from one another, and that the errors come from a normal distribution with mean 0 and constant variance. So in order to determine if the subjects and the sample are independent from one another, most of the time you're going to look at the way that the study was conducted. Was this a random sample of people? Do they have anything, any reason that you might think they might influence one another? Another time this might come up is in time series data. We haven't looked at time series data yet, but when data is collected over time, you'll have a problem with that independence assumption. Now, the second assumption is that the errors come from that normal distribution with mean zero and constant variance. We are going to use the SAS output to help us look at that assumption. So looking here, what we've got is some different plots dealing with the residuals and predicted values. In particular, the one I'm going to look at is this one in the bottom left-hand corner. Notice this is a histogram of the residuals. And what we can see is these residuals are almost normal. There is a slight right skew to them. And we see that the mean of them is close to zero. It's not exactly, but it is close. So even though the assumptions aren't exactly met, they are fairly close. So this ends the Module 9 SAS video. So as a reminder, these videos are just the basics kind of to get you started. You are probably going to have other questions that as you work with your data or things that you come across. So please ask about those. Don't forget that there is that SAS help page on Canvas where I'm going to be posting lots of good links with additional tutorials and information, as well as when you all ask me questions, I'll also post answers and code for those on that page as well.